I'm giving a talk today called The Challenges of Climate Change to South Florida and Everglades Restoration. We have been working, I'll go into a little more detail on it, but over the last couple of years, we've been looking very carefully at the effects of and the implications of climate change, not only sea level rise. Sea level rise arises out of climate change, but climate change itself is a change in temperature and rainfall. And that's what I'm going to be focusing on today for my talk. I've been working at the South Florida Water Management District for 16 and a half years, and most of my work there has been on Everglades restoration. I had previously worked on climate change before I even went back to graduate school in 1988-89, and did my dissertation and my postdoc largely on climate change effects on natural ecosystems. So this is a very logical combination of wetlands ecology, Everglades restoration, and climate change. Most of the media that you may have seen has been the focus, it's almost all been on sea level rise, and I think it's because it's a little easier to understand and it's much more certain than climate change itself and the effects of climate change. With sea level rise, there is a very immediate danger to human habitat and structures and a lot of the stuff that makes South Florida so attractive as a tourist destination. So I think that with the concern about sea level rise and the actual experience, we're beginning to experience sea level rise very immediately, especially along the coast, some of the coastal communities. In 2013, Rolling Stone came out with an article, this one called Goodbye Miami, and it was all focused on sea level rise particularly in Miami Beach and in some parts of Miami itself. Then a few months later, National Geographic came out with this article, this was in September of 2013, on rising seas, and part of what they looked at, besides New York City, they also looked at Miami as one of the cities of major concern. And then since then, there has been a tremendous amount of media coverage, whether it's on TV, whether it's radio coverage, whether it's magazines, popular media, scientific journals. There's been a lot of attention paid to sea level rise, particularly of great interest was what was happening in what they call the king tide, which is a combination of high tide that occurs in the fall. It's primarily in the fall. There's also one in the spring, but in October and November at the corresponding time of, I think it's the full moon and high tide. And what ends up happening is that the tide rises so much, sea level rises so much that in Miami Beach, in particular, and some of the other coastal communities, the drainage systems, the storm drainage systems that normally drain out to the ocean actually fill up and back up into the city streets. And so on days that were very sunny, you'll have 4 or 5 days in a week in October and in November where people in Miami Beach were actually having to walk around in boots, like waterproof boots. They'd have to take their animals out, their pets out to walk through seawater, and a lot of the cars, as you can imagine, were getting damaged and being inundated by salt water. And it was without any rainfall, just clear sky, clear day.
How recently has this been occurring?
This was 2013.
Oh, I know.
This was the fall.
Oh, I know, but was it noticeable in 2002, or how has it been
It's
increasing?
mostly been since about 2008 or 2009.
2008, 2009.
Excuse me. And part of the reason for that is that, and just to mention briefly, is that the Gulf Stream and the Florida current have slowed down. And so because the Florida current's bringing water in to the Gulf Stream and it's slowed down, water's piling up a lot faster in South Florida than other parts of the country, and it's happening all the way up to like New England. And it seems to be partly, there have been a couple papers coming out in the last few months, one of which states that it's probably mostly natural variability, and it's also partly because at the north end there's so much melting from the Greenland ice sheet, it's hard to separate what the effects are, what's most responsible, but it seems to be mostly natural variability in the Gulf Stream velocity. It's a big current, and it changes speed over time. But that particularly started happening around 2009.
So if it's natural variability, it's not a long-term trend. It will go down again.
Oh, natural variability could mean decades. It's probably related to some of the decadal processes. Well, yes, but it's been going up exponentially in areas around Florida Bay and the southernmost part of the state. So it can be a very big deal, and it may speed up again, but it's not clear how fast, and this could be permanent. We just don't know. We don't know. And the best oceanographers don't know, because there's only like 20 or 30 years of data on the velocities and how variable they are. So it's not enough time for knowing much of that. But hopefully it'll speed up again soon. One of the things that is of particular interest is very important to understanding what happens with sea level, is that the bedrock in South Florida is very porous, like this little spinning rock shows. Most of it's not quite that porous, but what ends up happening is that water can move in, fresh water can move through it, out to sea, and also the salt water can move inland into freshwater systems. And what happens is when we have well fields, which is where we get our drinking water from, close to the coast, and it's happened in Hallandale Beach, it's happened up here, it's happened a couple other places along in Palm Beach County as well as farther south, that the well fields have pulled up enough fresh water that it allows some of the salt water to intrude, and then it pulls salt water up, and we get our drinking water supply contaminated. So Lake Worth itself is on a reverse osmosis system now because we've had to shut down some of the wells.
Actually, 50% of it is.
And then
50% of it is still on the aquifer, and they're constantly in the process of abandoning the well. I mean, it was a great case study because they're abandoning the wells close to the sea and they're opening new wells further back.
Yeah, farther west. And that's exactly because of this. Also, one of the real big problems with sea level that we can't deal with, like most parts of the world can, like the Netherlands, is that with this very porous bedrock, we can't keep salt water out of the bedrock. Other places have hard bedrock. You put these big seawalls down, and it will block salt water from getting into the land. That doesn't happen. We can put them down 50, 60 feet, and salt water can still percolate up because of coming in from underneath that barrier. All this ties into some of the thinking about Everglades restoration, and that is that not only planners but engineers and scientists have been saying that we will be able to deal with sea level rise, pushing the salt water out with fresh water, because we're going to have Everglades restoration, and because with restoration we'll have more water in the interior, more water available to flush out the system. But that is not accounting for the fact that sea level is responding to the same thing that our freshwater systems will be responding to, and that is a change in temperature and a change in rainfall patterns. SERP itself is based around the idea that we will increase the amount of land in natural areas, so we'll be able to have more area for water to come in and to be able to restore some of the wetlands. It'll restore water quality, so we'll be able to introduce more water into the Everglades that is high quality, and be able to address the natural variability of the water patterns. Instead of having them held high all the time, there'll be variability where water levels will be higher in the summer when it's wet, lower in the fall and winter when it's dry. And water will be available for natural ecosystems as well as urban and agricultural uses. And eventually we expect to have, with restoration, have water flowing all the way from Lake Okeechobee unimpeded down into Florida Bay as it used to be in the natural systems. John?
So, but is this plan in effect? Are they actually following through with this restoration plan, or is it stalled?
A lot of the planning, a lot of the structures are still being built. We had expected when I first got to the district that Everglades restoration would pretty much be completed, all the structures on the ground by 2015, 2016. Most of them haven't even started yet because the process of getting the approvals and going through the Corps of Engineers is extremely painfully slow. And we did manage with SEP, which is one that is particularly targeted towards a lot of this in here, a lot of the restoration and changes in here. actually took less than 2 years of planning, but it won't be able to go into effect until a bunch of other stuff go into effect, and that'll probably be 2022, 2025, somewhere in there. So yes, everything is proceeding there with the big collapse of the economy or the slowdown of the economy. There's been a lot less money available from the federal and state agencies to be able to pay for some of these, so they've been slowed down as well. It's a very long-term process.
So is infiltration in urban areas of less importance? Because I'm on the Planning and Zoning Board, and every month almost I'm carrying on about we need to watch the pervious surface, and we want more pervious surface.
More impervious? More pervious. Which
Pervious.
city?
We want more pervious.
Yeah, which city?
Right here.
Lake Worth, okay.
Doesn't matter. The principle is we want as much water to go
Well-
to the ground table. Or is in fact that not relevant?
It's relevant. It's that will help in the short run. The whole thing is a lot of this is long term in terms of decades to a century out. And yeah, the reason I was asking is because I was on the tree board and did a lot of work with planning and zoning folks in Lake Worth, so yeah, I know yes, pervious surfaces will very much help, and decreasing impervious surfaces will be a very good thing for a lot of reasons.
Yeah, impervious means impenetrable.
No, pervious is when it can penetrate. It's like you've got your yard is either paved over or it's got natural sand and stuff. Water can move down in the sand, but not on the pavement.
And I know to the west of Okeechobee and we have the bottom of the Florida aquifer. Does that figure into your plan at all? I mean, the drawing water from the Florida aquifer. I mean,
most of my familiarity is on the East Coast and the
Okay.
East and Central. I know some about the bedrock. Most of the Biscayne aquifer goes over to about in here, and that's the one that's really
Okay.
holy. And I don't know what the structures are like exactly. I was looking that up a couple days ago, and I can't find a whole lot on that.
on the Florida aquifer.
On the western,
On the western,
what's
yeah.
going on?
Quick,
in the
well, I know
western.
that they've got like lots of mining and mineral rights over there too that are in Collier County and Hendry County, where everyone's up in arms about, oh, they're drilling in the Everglades. Unfortunately, they've had those drilling rights since the 40s. So.
Right, and I think surface land rights are different from mineral rights in Florida too. I know in Texas they are too, and it makes a big difference. You can own your property, but you don't own the mineral rights underneath it. And I think that's what's happening in Florida too.
On that same subject, you were saying that South Florida is limestone. So I know that they're drilling east of Naples. Is that in limestone there
I'm
too?
pretty sure it is. I think almost all of Florida is limestone. I don't know if it's as porous as it is over here. Again, I was reading on groundwater, and haven't had it. I'm doing work on that for something else, and need to go talk to some of the geologists in South who know South Florida geology better. I was reading about it, but it doesn't call it porous limestone like it does for the Biscayne. I'm not sure, but I know there's problems with any kind of below ground contamination of drinking water supplies, so I suspect there's probably a lot of karst terrain over there too, which is the stuff with the holes through it.
Yeah, so containing the fracking chemicals would be a lot worse than, say, in a place in the north or the Midwest.
Oh yeah. Yes.
Thank you.
Okay, so we decided a couple of years ago, it was a little over a couple of years ago now, that at the Water Management District, in order to try to understand the effects of climate change on hydrology in the natural ecosystems and in the agricultural areas and in urban areas, we would run some of the big models, the big hydrologic models that we use for planning, using, instead of the past historic climate, which is typically done for all the planning. We know climate is changing, we know some of the ways in which it is changing, and we wanted to see what the effects were going to be. This was in preparation for a workshop that was being held, big interagency workshop that included a lot of the research scientists for the Everglades, people from the different agencies, the federal and state agencies that we work with. It was held down at FAU, and so we ran the model to get the results, and that's what I'm going to be explaining to you the implications of those model runs, which was really pretty startling and rather very sobering. I won't say rather, it was extremely sobering for a lot of us who do research on the Everglades, on coastal areas and restoration. We wrote a bunch of papers. It just got published this week in the physical journal. They've been available online for months now, some of them for like over a year, depending how fast their review process went. But basically, the question that I had is it realistic to expect that we will have enough water in the Everglades and in Lake Okeechobee to be able to flush out the consequences of sea level rise? So we know we've got water rising from the east and from the south because of the coast, because of sea level rise, because of the bedrock and the stuff I went over really briefly. But we didn't know what's going to happen to ecosystems and water supply based on climate change itself. So what we did is we used, in the past, some of the folks at the Water Management District have done something called downscaling. It takes the modeling results that come out from the huge global models and apply it, downscale it, make it basically look at how those numbers translate to daily, weekly, monthly values of rainfall and temperature. And we ran a very simplified version of that because we only had about a month to run the models, and it takes several years to actually come up with what are much better numbers, and we're working on that right now to redo this analysis. But in the past, what it looks like based on the best results we've been able to get and the best implications is that we would have a 1.5 degrees Celsius temperature rise, which is just a little under 3 degrees Fahrenheit over the next 50 years, and rainfall would increase or decrease by 10%. Now that doesn't sound like a whole lot. When you've got 50 some odd inches of rain, that's plus or minus 5 inches. But the problem with all of that is that in South Florida in particular, there are two slides that are really important to understand. One of them is this one. Right now, all of the quality of life we have here is based on the fact, all of it is based on the fact that on an average basis, we have more rainfall than we have evaporation. The temperature drives evaporation primarily, and right now on a long-term average, we've got 2 to 3 inches more rainfall every year than we have evaporation. That is enough to recharge the groundwater. That is enough to provide all of the water for agriculture, to keep Lake Okeechobee functioning, all the water coming in from Lake Kissimmee, all the water going down to the estuaries. All that is dependent on that difference. Under these climate change scenarios, that is unlikely to continue to happen. And the explanation is basically in this graph, that right now, the ratio that we have is one that provides enough rainfall, enough water for our water supply. Temperature increase translates to an increase of 7% of evaporation, which means evaporation is going to go up 7%. And unless rainfall goes up at least 7%, that balance is going to change. If it goes up as much as 10%, we'll be fine. Things won't be much different than they are now. In fact, we'll have a little bit more water to deal with. Everglades restoration will go ahead fine. And yes, indeed, we probably will have enough water to start flushing out and at least delay some of the effects of sea level rise. However, the models are showing primarily rainfall is likely not only to not stay the same, which would be here on this solid line here, but actually decrease. That means instead of having, like if we had the same amount of rainfall every year, that means we would have a 7% deficit relative to what we have now. And if it goes down 10%, it's a 17% difference of what we need on an average per year. That has huge effects ecologically and the quality of life in Florida. Right now, temperatures are going up. They have been going up. In the 1950s, based on what was happening at the temperature ranges in the 1950s, warmer temperatures of 80 degrees or more they're starting earlier in the year, and they're lasting longer towards the end of the year. So we already know that, and that's the one thing we're pretty sure that the temperature predictions are probably right. So temperatures, that 7% increase is pretty solid. What we don't know is what's going to happen with rainfall. So what we did was we said, okay, let's look at the effect of a 10% decline in rainfall. What does that mean? Is that really huge or is it not so big? This is the second part that's extremely important about understanding climate change in South Florida. The Everglades soil is not normal soil. It's not like it is in most parts of the country and on most of the land areas that we have always, that some of us have lived if we haven't lived only in Florida. It's not mineral soil. It will disappear if it gets dry. If you have normal mineral soils, the normal stuff, you could have, 10 years of drought and your backyard would stay the same level, stay the same stage. If you had 10 years of drought in a peatland, that will decrease the level of the landscape down several inches. So you would continue to see your soil, your backyard soil.
So why is that? It's like a sponge drying out,
It's worse than that. It's that the soil itself is, this is what's called Everglades peat or muck. What it is it's partially decayed vegetation. As the sawgrass grows and the leaves drop, like they drop down here, and they will fall into the water and they start to decay, but the decay doesn't continue fully. And so over thousands of years, we built in South Florida, the soil's built up, where around Lake Okeechobee, they were up to like 20 feet of soil, 20 feet of peat, and it decreases in the volume and in the depth down to Florida Bay, where it was very thin originally. When the soil dries out, then it just finishes decomposing. So you have a little bit of stuff that's not decomposable, but the rest of it will disappear as CO2 into the atmosphere. So we will not only lose the peat, but we also increase the amount of CO2 emissions. And carbon dioxide is a major greenhouse gas. It is the major greenhouse gas. So in South Florida, if rainfall exceeds evaporation, we can maintain peat. We can continue to accumulate peat, or the Everglades can under some conditions. But if rainfall is less than evaporation, that doesn't happen. There may be local areas where there's still enough rainfall, enough water coming in from different sources to sustain the peat, but for the most part, most of the Everglades peat will disappear over long enough time with this, and it doesn't take a hugely long time for peat to disappear.
Martha?
Yeah.
And when peat is gone, what is there?
I'm going to show you. I'll tell you all about it, because this is super important. Most people who do Everglades restoration, most of the politicians have no idea that this is peat, and peat is not like normal soil. They've always assumed it's like normal soil, and it's not. So, initially South Florida was covered with a lot of bedrock. Over thousands of years, the peat that was there, pre-drainage, back in the 1800s up through then, peat was very deep. There was plants and water on top of it. And it seemed like, it's like in the Everglades agricultural area, it would be perfect for agriculture. So in efforts to turn the Everglades into huge farmlands, they put in canals and drained it. The peat then began to disappear, both because of drying out and because of big peat fires that burned it. Peat's the same, it's the same basic stuff that they use for fuel in Ireland and Scotland and large parts of Northern Europe. It's very good at burning. When it starts to burn, it can burn for a long, long time, even with additional rain coming. There were huge peat fires in the 1930s and 40s in the Everglades. There was also huge amounts, because of that, of carbon dioxide emissions. We're not sure how much, but there are some estimates now. And eventually what will happen when enough of the peat disappears, you get areas like you see down in the southern part of Everglades, which is where you have bedrock emerging through what had been peat. You have little pockets of peat, and you still have some water, and you still have some plants. Most of them are not wetland plants. Right now, in the regional planning being done in South Florida, they have not addressed at all the issue of how much CO2 is being emitted by the peatlands. They've looked at the amount of carbon dioxide from all of our activities, driving cars, heating and cooling our houses and so on, but not from the peatlands. It's an 18% difference. There's 18% more that they didn't account for, probably because of peat loss. When the peat dries out, this is what it looks like. This was in 2011. There was a drought. It wasn't an especially horrible drought. It was a typical, normal, to me it seemed like a horrible drought because it's the worst one I had really been looking at carefully. But the Everglades, here's like sawgrass, then the peat was here, and it's all cracked and pretty much dry, and water levels were about 1 to 2 feet in this area below ground. In some places it was as much as 3 feet below ground. We had a big surface fire that if there had not, it started to rain right when this fire was burning, it could have easily turned into a peat fire. It did not. But basically in the scenarios that we looked at with the model, it looks like overall every year on an average basis water levels would decrease by 1/2 to 3 feet depending what part of the system that you're talking about. Annual surface water, the time that water was above ground would decrease by 10 to 50% per year, and the droughts that would happen would be longer, more frequent, and way more severe than what we've been used to seeing. Droughts would probably lead then to reduced peat depths, higher carbon dioxide emissions, increased wildfires, the number and intensity of those as well, major changes in plant and animal communities, because if you're losing wetlands, you're going to be somewhat facilitating more upland species. When we have droughts, when we have areas that the peat's been dried for year after year, we're getting upland species coming in. And the northern parts of the conservation areas are considered habitat for deer now, so the Fish and Wildlife Conservation Commission has real problems if the water depths up there are over 2 feet, because at 2 feet the deer get stressed, and I'm like, it's a wetland, the deer aren't even normally there, but it's an issue now because the hunters get really upset because, well, deer have always been up there. It's like, well, they haven't. But it's a really huge issue, and eventually it means that we will have a reduced water supply, that unless urban people we can desalinate water, but the natural systems don't have an alternative, and agriculture really doesn't have much of an alternative. Peat loss in the Everglades agricultural area, that's the area just south immediately of Lake Okeechobee. In 1925, around at that time, the peat level was around here, and this was a boardwalk. By 1951, there had been about 3 feet of peat lost. By 1990, it's at the same post, or the same area, in the same near the same building. It's in Belglade. There had been over 6 feet of peat lost. So the soil levels had dropped 6 feet, and it's probably been more like 7 feet now. They've been a bit smarter about keeping it wet and reducing the rate of loss. Parts of the sugarcane fields, some of the sugarcane fields are already down to bare rock, and they can't even grow crops. And part of, for instance, in this part, this was a photo from 2005. Vegetation changes. This is what the natural Everglades look like. You've got tree islands, you've got standing water, you've got sawgrass and other aquatic species. When these plant communities get really stressed, then it allows plants like the old world climbing fern and other major problematic exotic plant species to come in, and they end up, the lygodium, the climbing fern strangles all the trees on the tree islands. This is very typical in a system, what happens in a system that is stressed. And eventually, this is down in the pine rocklands. This was probably shallow peat, and when the Everglades was started to be drained in the early 1900s, a lot of this converted, the peat was lost. This is all bedrock. The pine trees are growing in pockets. They're like lower areas where there might be a little bit of peat, where there's a little bit of water that stays long enough to support the tree species, but this is not what I think of when I think of Everglades wetlands. That's not what we're targeting, but it may end up, it's already happening in the northern part of the conservation areas. There's areas that I helped somebody else go out and do peat cores, and there was only 8 inches of peat above the bedrock already up there, and the water managers are working very hard at keeping that part of the areas hydrated now, so that all year long we have standing water up in that northwest corner. It's one of the few areas we're able to actually do something active, and mostly we can't. There's no way to get water into some of those areas. So bottom line is our water supply, whether it's for natural systems or it's for drinking water, they're likely to be greatly reduced. Surface and groundwater recharge are affected by Lake Okeechobee, by the water in Lake Okeechobee, which goes immediately into groundwater. All of the wetlands go, the water that's above ground filters down, becomes groundwater. And Lake Okeechobee is looking at the same, when the people looking at the effects of climate change on Lake Okeechobee, there'll be water levels at 4 and 5 feet. We've never had water levels that low in Lake Okeechobee, and it would all be pretty much muddy. Pretty much can't get it out. So it's a really huge problem, and it's something that is, again, it's just so mind-boggling. I think a lot of people just don't want to think about it. It's like, sea level rise is too much to think about, and you're looking at loss of water in the Everglades. That's even worse. So it's something to know about. It's something to keep aware of if you're going to be talking to public officials, that problems down here could be a whole lot worse than what they're thinking about.
I'm thinking of this huge push to build out our South Florida.
Yeah.
And I'm understanding that our legislature they have bills that would take away local control for development, because we've been standing up and saying no, not completely, but enough to make them unhappy.
Yeah, there's
so there
been
could
stirrings.
be huge communities built out
Yes.
west, let alone the high rises on the coast.
Right.
So we're doing that, and what I'm hearing you say is we're going to have likely, we don't know, but likely diminishing water. So we're not going to have water supply. For an adequate water supply for the numbers of people.
Again, if they're willing to pay for water, they can probably get water, because there's plenty of salt water available to be desalinated and could be drunk. The problem is the natural systems won't survive, can't survive, and we cannot provide them enough water in any way, shape, or form. I think that the entire area, the conservation areas, water conservation, which is what I look at, Water Conservation Area 1 all the way through Everglades National Park is probably 2,000 square miles. There's no way we have enough water for 2,000 square miles of natural systems. And that doesn't count the demand for agriculture north and south and east and urban areas.
Do you know how much of the wastewater from the developments goes back into the ground and how much goes in the canals or out? I mean, as long as that water is not actually wasted, in the sense that if we put it back into the ground, it's still there, because the ground systems will clean it anyway. It's still fresh water, so it's important that we keep the water in the ground as much as possible and not let it flow out in the canals.
Problem is, Florida is very flat. There's no place to put a lot of it. Even if you put it underground, there isn't enough space, because we rely on surface storage for a lot.
Yeah.
Lake Okeechobee itself is a huge water storage system. And the canals are essential to managing water, both for flood control, for water supply. We have to have the canals, and we have to operate them in such a way that we lower them if it's going to be raining hard, or if a hurricane's coming through. We raise them in the winter to keep water available for people to drink and agriculture to use for their crops. It's really complex, and it's something that it's not my major forte. I know people that deal with this day to day, week to week, and it's a huge issue.
Right. I'm just pointing out that just because we give water to people in development, it doesn't mean it's necessarily gone. We could make sure that it wasn't gone. We could infiltrate it if we made the effort. I mean, reverse osmosis sounds like a good idea, but it's energy intensive.
Yeah, it
Any
is.
desalination is energy
It's
intensive,
expensive.
so it's increasing. Well, it's expensive, but it's using scarce resources, and it's actually added climate change because it's more energy we're using to recycle that.
Depends where we get the energy too. If we can use, we have a lot of sun, but FP&L won't do much with solar power in South Florida. It's way behind.
Well, we need that for all the other uses. We don't need to increase the water treatment burden, on energy, because we don't have enough energy as it is, as you point out. And people are working on solar power desalination, but it doesn't seem to be cost effective right now.
If it's expensive enough, it'll be fine.
It will be, finally. They've got a competition going on, demonstration going on in New Mexico right now, how to do like natural desalination. How to do that. Working on it.
Well, everything's
There's
gonna be
enough-
more expensive, because the food's all gonna have to be imported if it can't be grown.
There are a lot of implications
Okay.
way
Right.
beyond what I've talked about here.
Yeah, another.
One thing I wanted to say about what you're saying about the development along the coast, there are a couple issues that are going to be coming into effect, and that is FEMA. Most of the country is not going to want to be paying billions and trillions of dollars for all of the damage done by hurricanes and sea level rise combined in South Florida. And there are huge questions that the real estate agents and the banks are going to have to be dealing with. And right now, sea level rise will be affecting the buildings built today along the coast within the time of the mortgage. You give somebody a 30-year mortgage, and their house isn't going to be available, isn't going to be usable or reachable. It might be reachable by boat, but they're not going to be able to guarantee that people will have access to their houses, or that there's going to be the support services for fresh water, etc., right along the coast. That is a huge issue, and I've heard that attorneys have the real estate attorneys and some of the planning attorneys are having to start looking at those issues. So that may be that the state, it doesn't matter what the state says, local governments and the banks may not give mortgages for buildings on the coast. The thinking is, I think they're betting on the fact that you can put a building up and maybe in 30 years it'll be gone, it won't be usable. But in the meantime, the question is who's going to be liable for all of that? And cities aren't going to approve
And
it.
where are those people gonna go?
Well, there's a lot of place inland. There's a lot of land
Savannah.
inland.
But the thing is that they're gonna get, it's gonna put a stress on the places that think they're safe. So yeah,
I'm not
have
talking
somewhere to
just in
go.
Florida, I'm talking inland.
Yeah.
But then those places will be hit by long-term droughts or massive flooding and more extremes of climate.
Right.
It's such a complicated issue that
It's a big domino effect.
it's even hard to get my head around what would happen with the Everglades. And a lot of us who do research are trying to look at, okay, for the system that we know, what are the implications of more flooding, long-term droughts? What's that going to do? It's a huge, huge problem, and most planners don't want to think about it. Most governing officials don't want to think about it. Other countries are going, yeah, we got to think about it. We're going to deal with it now, and the U.S. just won't for political reasons. So I don't have to preach to you guys about changes in lifestyle and demands that we make, because you all are Quakers and pretty frugal in general. But the regional, state, and national governments and our political leaders, our planning leaders, have to be pushed hard to plan for the kind of futures that we are probably going to be seeing within their lifetimes and their children's lifetimes. We need to figure out how to mitigate for all of these problems and to adapt if we need to. It means, like moving inland, figuring out a whole different suite of planning issues. Right now, like in Lake Worth, the city commission would not even consider raising road beds with some of the money that they wanted to borrow in order to start to adapt for future changes in sea level. Lantana is an area, if we're looking at saltwater intrusion, Lantana's got a lot of saltwater intrusion inland. Jupiter does. Delray Beach does. They're already seeing some of the flooding areas, some of the flooding that happens in, like the high tide, the king tide area, along Flagler and West Palm Beach. And parts of Delray are already seeing that in some of the communities that are right on the barrier island and the inland, the immediately far eastern part of the mainland in Delray Beach. It's not like it's not happening in Palm Beach County. It's just not happening
Dramatically
in
enough
Lake
for
Worth
people to-
yet.
Yeah.
But that will change.
When you say seeing saltwater intrusions, it means that wells are going brackish, or
More than that, in parts of Delray, on the, let's see, here's the barrier island here. Well, let's see for you guys. Okay, the eastern part, there's a fairly wealthy community in Delray Beach, right along, I can't remember the name of it, right along the intercoastal. It's already getting the same kind of flooding. There are photos we have of people's houses and the roads being flooded with salt water because of the king tide that was this past
saltwater flooding.
2013 and 2014. And then the same's happening on the west side of Barrier Island up there in some of those houses, because that land is lower than, 2 miles away or a mile away.
Martha, one thing I just wanted to complete about desalinization is that there is waste from desalinization. And if we do it on a large enough scale, what will that do?
Where do we put it?
Yes, yeah. And if that's dumped into the ocean, how will that change? We're already losing fish, like crazy.
They haven't talked about salt ponds. I have no idea if, at least at some scale, salt ponds would be a possibility of dealing with the brine. I don't know. But yes, you're right. There's also talk about, injecting it underground.
Inject stuff, God.
All that stuff, yeah.
Offset the glacier
Can't be
melt.
good.
I don't
It's a
wanna
drop
say
in
that.
it's a drop in the bucket. Actually, it would be compensation. It wouldn't matter if you put it back in the ocean because we're getting more fresh water coming from the lake. That's what's causing it.
But it's,
Melting ice
thousands
water.
of miles north.
We
Yeah.
need to send it up to
Ocean
Greenland.
Wouldn't it increase the salinity of the
Dumping
coastal
green.
waters if you're just dumping it right back out, and then you're gonna have to suck
It's
that
such a
same salt
tiny-
back?
It's such a tiny amount compared to the bulk.
Probably.
Yeah, but human beings have said that about so many things, that are not insignificant. I don't have faith that when we decide to do different processes, chemical processes, that we actually think it through carefully.
I actually heard someone yesterday on the radio talking, the solution to pollution is dilution, and I'm like, yeah, see where that got us. I'm like, wait, this is 2015. What's this problem? It sounds like the 70s,
Is there a specific rainfall breaking point? I mean, right now, what's the stability point where evaporation is balanced with enough water to recharge everything? Like 50 inches per year, 55? Or you don't like
I don't
talking like
know.
that?
I don't know. I know from what I've seen, it depends what part of the Everglades, what part of South Florida you're looking at. But average, we get 55 inches of rain. We get about 52 inches of evapotranspiration, which is evaporation plus plants pulling water up. And
So
it's that 2 to 3 inch difference.
It's about the minimal right now then, the 55 inches or
I don't know.
Okay.
I don't know.
And another number, you probably know. What's the latest statistic on sea level rise? How much is it actually going up a year?
I'm working on that for a paper. I'm going to be giving it a talk in a couple of weeks. And there are various numbers, but the area of Virginia Key, Key West, areas in Taylor Slough actually has risen 10 centimeters since 2000. It's been exponential since 2000.
And it's not even sea level rise. In
That's
some
that.
parts-
That's the because of the slowdown of the Gulf current. I mean, the Florida current and the Gulf Stream.
You're probably coming close to when we have to end. Unfortunately.
Well, thank you very much for inviting me to speak. There's lots and lots of stuff for you guys to think about. And there are other folks who can talk to you if you want to follow up on any of this.
Thank you, Martha, very much.
Thank you.
Thank you, Barb.